Thank you all for joining us today for this Reactor session. Before we start, I have a few quick things to go over. Please ask questions using the live chat. We will be looking at those throughout the session and then replying to them at the end. In the chat, I will also be sharing some links to the Reactor meetup page and monthly newsletter if you are interested in checking out what other sessions we have going on. Today's session is being recorded and will be on the Reactor YouTube page afterwards, and I will share a link to that shortly. Finally, I will share a link to our Reactor survey. If you have a few minutes, we greatly appreciate your feedback. I will now pass it over to Stephen.
Thank you very much, and welcome. My name is Steve Murawski, and I'm a principal cloud advocate here at Microsoft, and I lead the DevOps team. Now, before we get into Microsoft's journey from waterfall to Agile, we're going to talk a little bit about our DevOps transformation, if you will. And we should probably level set on what DevOps is. Now, if you ask 10 different people what DevOps is, you're probably going to get 20 different answers. Now, at Microsoft, DevOps means something very specific to us. DevOps is the union of people, process, and products to enable the continuous delivery of value to our end users. Now, I said this very carefully because every word has meaning. I didn't say continuously deliver code because that'll just give us piles of code and sitting on a source control server somewhere, and that really doesn't do anybody any good, right? And I didn't say continuously deliver features because we could be delivering features sprint after sprint, but if it's not what our end users need and want, are we just wasting our time? So what DevOps ultimately is about is continuously delivering value. And why is this important? Well, the bottom line here is that the speed of business is crazy fast and life is unpredictable. This last year really shows us that. And the only way that dev teams and operations teams can keep up is if they adopt DevOps practices. If they don't, they won't be able to keep up. And here's the sad truth. If you don't adopt these DevOps best practices, your competitors will, or they may already have. And once they do, they'll be in position to out-innovate you. And when that happens, you start to become obsolete. And none of us wants to become obsolete. Now, this is the exact position that Microsoft found themselves in around the 2010 timeframe. But, we were still delivering code every 3 to 4 years, but our competitors were innovating faster. And this is a very scary place for us to be. We knew we had to change. We knew we had to shift and adapt and adopt DevOps practices. It was difficult. One of the things we had to learn was that if it hurts, we need to do it more often. When things hurt, we usually tend to avoid them. And what really hurt for us was pressing that deploy button. Every time we pressed that deploy button, guess what? Things would break. So what did we do? Right? We tried to avoid it. Now, if I had some changes to check in, maybe I had 20 or 50 lines of code, I would try to avoid deploying. I'd say, well, maybe I'll just wait till the end of the sprint. Because I knew if I waited to the end of the sprint, I would push off that break today, and I wouldn't have to deal with that big headache then. Well, guess what? That delay to the end of the sprint gets pushed out further and further. And now we're going from the end of the sprint. We'd be like, well, why don't we deploy at the end of the month? Or maybe at the end of 6 months. I might even get it pushed out all the way to the end of the year. And so what was 50 lines of code has become thousands and thousands of lines of code that change many, many things. And if we push that into production, things just get much, much worse. Of course, things would break, and then we'd have to go find where in that huge set of changes to troubleshoot. And this was very important. It was a very important thing to learn, right? If it hurts, don't avoid it. Do it more. Do it until we get better at it. And so that's what we did. We built out these DevOps pipelines. We pressed deploy. And guess what? Everything broke. But that's okay. We fixed it again and tried again and again. And still things would break. But less things. And slowly, over time, iteration after iteration, we got better. Until eventually today, we can press that deploy button and have a high degree of confidence that our deployments are going to work. There's a saying in our industry where they say, don't deploy on Fridays because you're going to have to work all weekend. to get everything working. Well, we don't have to worry about that anymore. We know our pipelines work. We know we can press that deploy button on Friday and everything will just magically work. Well, why? It's not so magic, right? It's because we've done this over and over again. We found what hurt, which was our pipeline, and we improved it day after day until they just worked. So back to our DevOps journey. Our story began when we first started Microsoft. We came into being in the 80s, 90s, and early 2000s. We dominated. But the way we did things was interesting. We deploy new code when we put out a new product every 3 to 4 years. So every 3 to 4 years would be a new version of Windows or a new version of Office, a new version of SharePoint, new version of TFS, and that worked great for us. Back then, we were really waterfall-like, which may be a situation you find yourselves in. But the world started to move much quicker, especially around the 2010 timeframe, and we knew we had to make some changes. One of the places that we had to make changes was our org chart. Now, I love this picture here. Yeah, I think it's hilarious. Yeah, it's a joke, but like most jokes, there's a grain of truth in there. And if you look at how Microsoft is organized in this cartoon, it has all these little islands, big islands, and each island has deep hierarchies within it, and these larger groups that all have guns pointed at each other. Right. And each of these groups, one would be the Windows team, one would be the SharePoint team, one would be Office. Now, today, one of these islands would be Azure DevOps Services or the TFS team at the time. And we had these separate teams, and they're all islands unto themselves. They got to decide how that team was structured, how they functioned, right? And they had these guns pointed at each other, and it really was kind of like that inside of Microsoft. They were hyper competitive with each other, all these different teams. And we created this culture at the time because we thought it worked. We fought tooth and nail and competed against each other for resources and time. And by the time a product would go into production and out to the public, the product was forged in fire, which we thought made it better than ever before. That was our thought process. And when we were deploying code every 3 to 4 years, it actually worked out pretty well for us. However, if you're trying to move quickly and you have all these different guns pointed at each other in the organization and you're fighting each other constantly, you're not going to be able to move quickly, right? Everybody had their own CI pattern. Everyone had their own deployment pattern. Everyone had their own different support structures. No reuse went unpunished, right? So we found that we created this very toxic environment where everyone fought with everyone else. And to be really successful at DevOps, we need to be successful at collaborating and working across teams, not fighting them, right? Rather than fighting each other, we needed to use our scarcest resources, our people's time, effectively. Luckily, around that same time frame, we got a brand new CEO by the name of Satya Nadella. And he said, this worked great for us before, but if we continue down this path, we're going to become obsolete. What we need to do is create something called the One Microsoft Initiative, where we are one company and we're all working together to be successful no matter what it takes to achieve the company's goals, not just individual product team goals. So we need to put the guns away. We need to start working together. He also had an idea that we should have one engineering system. And by that, I mean our build systems, our release systems, our source control systems, work item tracking, and such. Now, back in the day, each individual product group, we could pick and choose exactly what tools we wanted to use, which meant everybody used different tooling, right? Because you're trying to get an advantage. And if team A was using one thing, well, team B had to use something different to try to be just a little bit better. So that made collaboration really difficult across teams. We'd have different source control, different build systems. We didn't even speak the same language really when it came to working across teams. So Satya said, what we're going to do is we're going to create one engineering system. And then he asked an interesting question. Which system should we use? And he thought, well, don't we package and sell an engineering system in-house? Well, of course we did. Team Foundation Server, TFS. Then Satya asked a very embarrassing question, which is, all right, so who inside of Microsoft is using TFS? And the answer was no one. Not even the TFS team used it because they used other systems. So Satya said, hey, this is ridiculous. The only way for us to build a world-class DevOps system is if we use it ourselves, because then we know it works and we know it doesn't work. We can go in and fix it. And so that's what he mandated across the entire Microsoft. We're going to use one engineering system, and it's going to be, well, at the time it was Visual Studio Team Services. Now it's Azure DevOps Services. So today we know this works because these are some numbers from about 2 years ago. The numbers today are even bigger. And this is just inside of Microsoft. So how many engineers are using Azure DevOps Services inside of Microsoft? Over 96,000 engineers every month. How many builds? 6.3 million, right? How many work items are viewed every day? Over 5 million work items. Over 163,000 deployments a day, right? And again, these are old numbers. These numbers are even bigger today. So we know these engineering systems scale because we use them internally, and these are just our numbers. This is only Microsoft's use of Azure DevOps Services, not necessarily any of our customers. And what we use is the exact same thing that everyone else has. So we know it works because we use it every day. Now, back to our story. Now, our journey, right? I said we used to deliver software about every 3 to 4 years, but around the 2010 timeframe, we started realizing that we were being out-innovated. And this is really bad. Let me give you an example. Around 2008, we came up with a new thing for work item tracking. Now, a colleague of mine was actually working on the product team at the time. He told his friend about the feature. His friend tried it out, and she called him on the phone because phones were a thing back then. And she said, what didn't hop into a Zoom or Skype call or something like that. She actually called on the phone and said, hey, that's a neat feature that you wrote, but there's a bug. Now, my colleague, he's a pretty good developer. He's like, I don't write bugs. But in this case, he did. So he jumped in there and checked it out, and lo and behold, there was a bug. He fixed it, checked it in, and called up his friend. He told her, hey, I fixed the bug, and you'll get it in the next version, which will be in about 3 years. Now, that's crazy, right? But that's the speed that we were working at. And so we knew we had to increase that speed. So around 2013, we increased our cadence. And what we did was about every 3 to 4 months, we would send out a service pack to our end users and said, hey, install this. Now, this put us in a very weird spot because it made us move both too quickly and too slowly at the same time. How's that? Well, we were moving too quickly because every 3 to 4 months, we expected our customers to take this and install it. To install it, they would have to bring TFS down, install it, and then bring it back up. Now, usually TFS wouldn't work then, right? And then they'd have to tweak it to get it working. And all told, TFS would probably be down for a day or two. And they're like, wait, you want us to bring our company's engineering systems down every 3 to 4 months for a couple of days? Are you crazy? We can't do that. And so then they'd stop installing the service packs and they'd fall further and further behind. But this was still too slow. Even if they installed these service packs every 3 to 4 months, our competitors were still moving more quickly than us. We had to move faster. So to do that, we had to go to the cloud. Because by going to the cloud, it lets us move at cloud speed. What's cloud speed? Well, right now, it means every 3 weeks, like clockwork, new features can just magically light up inside of Azure DevOps Services or Visual Studio Team Services at the time. But what we don't tell people, but I'm going to tell y'all because I think it's super cool, right, is that every day, multiple times a day, we're pushing into production. We're pushing bug fixes every day. We're pushing to production. Why? Because we can. We figured it out now. We know how we can move at that velocity. Now, to get there, one of the first things we had to do was adjust our definition of done. This is our definition of done. I think it's a very mature definition of done. Not only does a user story have to be code complete, not only do we have to have a particular unit test that tests that user story, but we're not done until it's all the way into production. But that's still not done. It's not actually done until we're gathering telemetry and sending that telemetry back. That's how important telemetry is, right? How are people using this? What's the experience like? Now, this is a pretty advanced version of definition of done. And so people often ask, hey, should that be our definition of done? The response is, perhaps, right? But it's probably not where you start. DevOps is a continuous journey of improvements from one iteration to the next. You need to start with what hurts most, right? And fix that. And over time, your definition of done, your target that you're going to hit, will evolve until it becomes more mature. But we don't start trying to bite off too much all at once. Now, something else that we had to address was our team structure. Our teams were they're structured like this, right? We had program management, development, testing teams. Now, we had a very toxic relationship between our devs and our testers. In fact, they were fighting each other all the time. Our devs viewed the QA team as our enemies. Now, let me give you an example. At the beginning of the day, a dev would go to work. QA would give her a bug report of all the bugs that they found in her code. Now, she would immediately get really mad. And rather than starting to look at the bugs as chances to improve her code, she'd work through the bugs one by one and try to prove that she wrote the code correctly and it was tested wrong. Right? The QA team was the developer's first and best line of defense for shipping quality product at the time. But this toxic relationship existed across many teams inside of Microsoft between development and testing. And you even saw it in the interview process. You might hear a lead dev say something like, well, this person was great. I really like them, but I don't think they were technically quite strong enough. So they'd be great on the QA team. And we created this second-class citizenship within our QA teams, and it really shaped this toxic relationship. So what we ended up doing is we collapsed both teams and said, we've no longer got developers and there are no longer testers. You're just engineers, and quality is everyone's responsibility. Now, sometimes when we say it's everyone's responsibility, we really just mean that it's no one's responsibility. But in this case, it means that you are really responsible for your code and all the code that touches yours. That meant as engineers, we had to upskill. In fact, everybody had to upskill and get cross-trained. Developers had to learn how to build quality into the development process. We had to learn to write good unit tests. We had to learn to write code in a testable manner. And we had to learn things like how to write automated UI tests and things like that. The QA side had a little rougher journey. They had to learn how to write code as well as because ultimately before they were primarily functional testers. So they clicked buttons and followed scripts. Not all of them did that, but that was the primary goal, right? So they had to learn how to develop software. Now, not everyone could make this change. And we suffered some attrition. It was pretty rough to make this change. But there was support across our management chain, and reviews and incentives were aligned to help folks make the right choices. And our teams, they started to learn to write code again, to write code in a testable manner, to learn about quality. And eventually we did suffer some attrition, right? Our leadership didn't know at the outset how much we would lose, but we knew we were going to lose a lot. And we ended up losing about 20% of our engineering staff, which is a crazy amount. Nobody wants to lose good engineers, and we lost a lot of very good, very senior engineers who just could not make this change, both in the dev side and the QA side. But our leadership knew that this was a price that they were willing to pay, because now we could replace those people with other engineers that were really bought into this mindset. And so now we could start to move faster than ever before. Not just a little bit faster, but dramatically faster. It was a heavy price to pay, but it was a price that we had to pay at the time. Now, the other thing that we did is that we restructured our org chart and flattened everything out. Remember, we had these deep hierarchies, and that made it really difficult to make changes because in one particular feature, if you wanted to change a feature, it would span multiple teams. And you had to coordinate between each of those teams, and it became very difficult. So we created feature teams, which would own a feature all up. They would own everything about it, right? Now, the first thing that this allowed was it helped us to be much closer to our customers. Before, if our customers wanted to get feedback about a particular feature, who would they go to, right? The feature would span multiple teams to implement. Well, now we have a program manager that you can reach out to and talk to about your specific feature that you care about. It was so much easier for our customers to talk to us. In fact, they can talk to us in many different ways, right? They can talk to us through Reddit. They can talk to us through user voice. They can talk to us through Stack Overflow. They can even use Twitter, right? Now you could just tweet directly to one of our program managers and say, hey, I love this feature, or this feature sucks, or can you fix this, blah, 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 right? And by being this close to our customers, we can gather that feedback, and that helps us know that we're delivering value, and we can start delivering value faster than ever before. Now, by structuring our teams this way, by having feature teams that forced us to re-architect our application as well. So before we architected our application in layers, right? We had our UI layer, our API layer, a data layer, and the teams are structured to support those layers. So we had UI teams, we had API teams, we had data teams. And again, there were many teams that you'd have to span to implement one particular feature. It would cross through lots of different teams, and it made it really difficult to get work done. Now, right? So now that we have these feature teams, instead of designing things in layers, we have to design things in slices. And the team would own everything all up, the UI, the API, and the data layer. And they would go about gathering their own requirements to figure out what they were building. And they would own quality for that whole feature, right? And they would even own the CI/CD pipeline. So everything about that feature and the delivery of that feature was owned by the feature team and under their responsibility. And because we were much closer to our customers and we were becoming more agile, we can more quickly make changes within a feature to respond to our customer needs. This made it much better and faster for us. Now, each feature team, to give you an idea, we had about 800 engineers, and we had about 60 of the teams, which meant each team was about 10 to 12 people. Each team was self-managing, and they got to decide what they wanted to do, right? We had teams on the East Coast of the US, the West Coast of the United States, out in India, all over the world. It was a very global team. Now, before COVID, we required you to be with your team. You could join whatever team you wanted, but you had to be co-located with your team. And one of the reason we did this was what we found out when we tried to do it differently. We tried to do it where you could just join whatever team you were because we had pretty decent remote capabilities. But it just became too difficult to schedule and coordinate between people. Different time zones became very, very difficult. Today, it's much easier to do remote team membership. In the COVID world, right, where we're 100% remote, you can still pick whatever team you want to be on, but you have to be time zone adjacent. You need to be close enough where you don't have the hurdles of coordinating, because that's still important to us, right? But it's still kind of neat that we have a little more flexibility in location. Now, each one of these feature teams, they're independent from each other. They're self-managing and they're autonomous, but not 100% autonomous. That would be anarchy, right? So it's controlled, and we have what we call aligned autonomy. Now, there are certain things that we align on, like the types of sprints. You can choose whatever, if you're a team, you can choose whatever version of Agile you want to do. One team can do Scrum, one team can do Kanban, whatever. But there are some things that we have to align on. Now, once a year, we have what we call the Great Yellow Sticky Note exercise. And this has been an amazingly successful experiment that we ran. Every year, team members are allowed to pick which team they want to be on. Once a year, we have, as part of this exercise, and program managers come out and say, hey, join my team. My team's the best. We're using the latest JavaScript framework. Look how many customers we have. Look at all the cool technology we have. Join my team. And engineers will come up and say, oh, this is my first choice, this is my second choice, my third choice. And then based on availability, we get to pick the team that we want to be on. Now, what we found out, the most interesting thing here is that most engineers ended up not wanting to change teams. They didn't like change. They loved the team they were with. They loved the culture that they built. And they loved the people, right? You built friendships. But about 20% of engineers did want to change. And by giving them this choice, giving them the capability to change to something else, it made them much happier, right? For whatever reason, somebody might not click into a particular group. or with a particular type of work. And so you have the opportunity to change. So it's one of those experiments that we ran that became really successful. And we still do it to this day. Among the other things that we align on is our sprints, right? Our sprints are 3 weeks long. We used to have a team that could where they would be able to pick their sprint cadence and turn that cadence into whatever they wanted, but that was just chaos when we tried to coordinate that across 60 different teams. So now we say we start at the same time, we end at the same time, right? Our sprint length is 3 weeks. Why 3? Well, we tried 2, and that was too much time spent on coordination across the 60 teams. We tried 4, and that wasn't just agile enough. So what we really we ended up kind of with this Goldilocks. 3 seemed just about right, right? It was long enough that the coordination was worth the effort, and short enough that we could ship things relatively quickly. So we said, hey, that felt pretty good, and that's kind of where we're at right now. We've learned some things since then about communication and coordination, and so we're trying 2-week sprints again, but that's a work in progress. All right, so how do we coordinate at the beginning of the sprint? Well, we have a sprint planning meeting, and at the end of the sprint, we're done with, we press the deploy button, right? And we deploy at the end of every sprint. One of the things that we found out is that if you don't deploy, some things just don't get done. And it's really not because developers are lazy or that engineers are bad, but not deploying, or actually having that deployment, really does having that deployment deadline really makes sure that you accomplish the things that you expected to accomplish, and that you're using the tools and patterns that we needed to get them safely into production. It becomes really easy to, if you're not going to do that, to say, oh, well, I'll just catch that up on the next sprint. I'll have a little bit of time, I can do that. By forcing the deployment at the end, we make sure that we put the right emphasis on getting things production ready. Okay. So now, our deployments at the end of the sprint can take a long time because we do try to deploy very carefully throughout the entire world. We call it safe deployment, and we start with a deployment to a small segment of the population, and then roll it out to a little bit bigger and a little bit more, and then a little bit more. And eventually, it'll go out and span all the Azure DevOps instances. And that can take up to a week from pressing the deploy button at the end of the sprint. Now, after we press that button, right, we can take up to a full week, and that can sometimes bleed into the start of another sprint. But that's okay, because we're just starting that next work as the deployment is kind of finishing out, and we're getting telemetry, so we understand how the new features are performing in production. So we're at a good place to start our next sprint. Now, trying to coordinate all of our teams is difficult as well, because we can't all sit in the same meetings, especially with different time zones. So at the beginning of the sprint, we start with a sprint plan that says what we're going to do, and we email that to everyone. At the end of the sprint, we say what we've done, what we've accomplished, and then we include a video of that. And this has been an extremely good way for us to communicate what's happening across the 60 teams. Now, this is what it looks like at the beginning of the sprint. We say that this is our sprint plan, and since we're using Azure DevOps services to track our work, it means most of this email can just be automatically generated. And at the end, we say this is what we've accomplished, and we create our video. Now, the only rule for this video is it can't be produced, right? No smoke and mirrors, and it needs to be the real thing. I think that's pretty cool, right? And it's been a great way for us to communicate what we're working on, and for our leadership to see what's happening across the different teams. Now, before we used to send this email out at the user story level, but what we found out there was that was way too much detail. Most people didn't have the context for that. So now we moved it to the epic level, and that's much better. There's a lot less chatter, and it just works out nice and clean now. Now, across our teams, the way we do planning is we have our sprint planning, which is every 3 weeks, and we have a quarter, which is 4 sprints, and a semester, which is 6 months. And then, of course, we have our yearly planning. Now, since I'm a team lead, I'm interested mostly in our sprints and our quarters because a sprint, is 3 weeks long. And so I'm going to worry about what my product backlog is, how to prioritize that, and all the stuff that lines up there. And then every 4 sprints, I'll meet up with my sister teams. And we'll have meetings as well along the way to help shake things out because these teams are teams I might share code with or that we work on closely related topics. And so we'll talk about things like what we're working on, what we've got going, what we're going to be doing next. And a lot of the information starts to shake out for things like, oh, you know what? We might be evolving this API that you use. So let's coordinate on that. Or, hey, you need a widget to do something for your UI. We've implemented something like that for something a couple weeks ago. Let's use that. Or, right. A lot of useful information can come out of these quarterly meetings. Now, the leadership worries about the semester and the yearly plans, right? And they have a great big meeting and reprioritize our yearly plan as well as every 6 months that gets updated. But we've even got a rule in place where the leadership cannot look at our sprint backlogs because every time they looked at the sprint backlogs, they would want to micromanage a little bit of it. They just couldn't help themselves. They wanted to get in there and add some value. The problem is they didn't necessarily have the context to micromanage that effectively because we'd waste a lot of time explaining to them why we couldn't do what they wanted to do and the way they wanted us to do it. And so eventually we just said, you know what, leadership, leave the backlog alone. Tell us what you want us to accomplish. We'll figure all this part out right here. You don't need to manage our little section of the world. You just tell us what we need to achieve and we'll go get that done for you, right? Give us that long-term strategy. And, it was difficult to give up some of that control for our leadership, but they realized the truth in the matter. And they realized that they were really slowing down progress. So they agreed to it, and it's been working out really well. Now, the other thing we had to do was to fix how we did quality, right? Before we would write our code, we'd write code until we hit code complete, right? Pizza party time. And we weren't really done because that's when QA would start testing and they'd find a bunch of bugs, right? And the dotted line there, that's the bug count. And because it would build up and then you'd go back and you'd work on that mountain of bugs and you'd burn it down. And then they'd test again and you'd burn them down again, right? And hopefully you wouldn't get all the bugs, but hopefully you get quality good enough. And then the next iteration, you do the same. And this bug count gets higher and higher. And we've been in this position where our application can get to a point where it's so fragile that every time you try to make a change, right, or you fix one bug, 5 more things break. Now, this gets to a point where we can't add new features because we're just stitching things together to make them work. And what that is that's our technical debt spun out of control and it cripples innovation. What we needed to do was to make sure that didn't happen. And we came up with a rule that said at the end of every sprint, you must burn down all of your bugs. You cannot carry bugs from one sprint to the next. Right? And we created something that we called the bug bar and bug cap, which is that for every engineer on your team, they could only carry 4 bugs from one sprint to the next. And why 4? Well, in theory, or what we thought was that you could burn down 4 bugs within one sprint time frame. And if we could spend that one sprint, we'd end up with 0 bugs. Well, we're so serious about this bug bar that we actually have a report that shows what the bug bar is for each team. Now, if a team is over the bug bar, they're not punished, but they're not allowed to take on any new features for the next sprint. And we've seen a variation actually of this practice, call it error budgets in the site reliability engineering world. So we called it bug cap. Other people may call it, error budgets, but you're not allowed to take on any new features for the next sprint. And then you have to burn down those bugs. And it's not a punishment. It's just a way to make sure that we don't carry forward that technical debt from one sprint to the next. And because of that, our quality is much better than it had been before. The other thing that we had to learn is that what you measure really matters, right? And we had to measure very carefully, because if you measure things that don't matter, that's what drives behavior. And so we've got this mantra, right, which is measure the outcome that you want to happen. If you don't measure output because you measure the output, we're going to game the system, right? That's just how people are wired. If you tell me to, that I'm going to get counted on how many bugs I burn through and fix, I'm going to go write myself a new minivan, right? The numbers, those numbers really don't mean anything, right? So things like, let's use things like code coverage, right? The percentage of code that's covered by tests, it's an important number, but it's an important number in a certain context. It doesn't actually drive our business value. It can give me cues to figure out where I need to improve my test coverage, but it's not something that, for example, Scott Guthrie, who runs Azure, is going to care about. He's going to care about what my customer experience is like on Azure, and are people actually, accomplishing the things that they're trying to do. So, we don't track some of these things that might be useful numbers in particular context, but don't actually mean anything in the overall delivery of or don't mean anything directly in the overall delivery of our service, right? So, right, if I did measure code coverage, it could be really easy for me to game that too, right? Because now I could write a test that runs through and just make sure every line of code runs, but doesn't actually test anything. And, it may seem kind of like a joke, but I've seen that happen. I've seen that happen in production, right? People end up doing that because not everybody's going to go review every single line of tests, but they are looking at that code coverage line or that code coverage metric on the dashboard, right? So we want to focus on measuring the outcomes that we want. Important things like mean time or cycle time, or how long does it take from when we start work to when that work shows up in production? Or how long does it take to have an idea and then have that idea cycle all the way through everything, all the way out into production, right? Or how quickly do we find live site incidents in production, right? How quickly, once we found it, do we get to fixing it, right? Those types of things are important. We still do gather performance numbers about our individual engineers, but the important thing is we don't use those numbers to reward or punish, right? We use these numbers to help guide and help coach, right? So we want to avoid looking for providing incentives to game the system and focus on the things that matter to us, right? Because engineers, we're wired to win games in a lot of cases, right? You put a point system around something, man, and I am all over it. So, I try to use these numbers to help. Instance, if productivity is dropped for one of my engineers, I may go up to them and talk to them and say, hey, I've noticed that the productivity has dropped. Is there anything I need to know about? Right? Maybe there's a new framework we're adopting and we're kind of working out the kinks of that. Or maybe the person's got something going on at home and things are difficult, right? Maybe we need some more training. Maybe we need some time just to get used to it, right? Or we might find out, hey, maybe I don't want to be on this team anymore. And we can use some of these numbers to help us get a better understanding of what's happening inside of our team, but they're only a tool to get that. They're not the full story, right? And right, so we can't use these numbers to punish or to be punitive. They're really just indicators for us as leads to be able to find out, how things are progressing for our teams. Now, right. So how do we actually make our engineers, do the right thing? Well, we make them do the right thing because we help make them feel some of the pain from doing the wrong thing. And what I mean about that is, like, for example, my coworker that I mentioned before, really good developer, writes code at a crazy speed. Now, he didn't often feel early on in the Microsoft evolution, while we still had testers, right? He didn't feel the pain of that. He'd write a bunch of code, somebody would find some bugs, and a junior dev might come along and have to fix those, right? So he would just be on to the next thing, and he would never really feel the pain of the code that he wrote or the bugs that might have been left behind. Now, right, so now what we have is, if you write it, you run it. And if you write it and you run it, right, now what that means is that if we go into a live site incident, it could be bad, right? Azure DevOps Services, for example, that team runs critical workloads for a lot of customers, right? And so if I write bad code and it goes out into production and it causes damage to customers, it's not going to be our tester coming and pestering me about something. We might be getting a call from Scott Guthrie and down the chain, right? And so Scott Guthrie calls down, right, and he calls our management chain all the way down to me and the program manager who's in charge of the feature, right? They're going to get the two people on the team that are on call that week or on call in that period, right? And once we do that, right, we're on a bridge. And this bridge, and responding to an incident sucks, right? I've been in operations roles across my career. It stinks to be on call, and it stinks to be on call and pulled into an incident, because you have to get up to speed really quickly. You have to figure out what's going on, quickly triage, while you're reassuring your stakeholders that you're doing all the things possible, that you're going to get the incident resolved, that communication's going out to the affected customers, right? There's a whole lot of things, and these things never happen, at like 10 a.m. on a Tuesday. They always happen at 2 a.m. on like a Thursday or Friday night. So, at 2 a.m., it sucks no matter what time zone you're in. So you get this call, you join the conference bridge, and you're getting pinged every couple of minutes. Is it fixed yet? Is it fixed yet? And right, and you're not allowed off the call until you've alleviated the problem in production, and you figured out why that problem occurred. So, the code that you write and ship, and the code that your team writes and ships, becomes your responsibility. And you want to make sure that you never get on this call bridge ever again, right? So when you have that experience, right, every check-in that goes through a pull request review or a code review, right, is going to get scrutinized by your teammates. It's, there's an incentive to make sure that the things we're doing well, and we're doing them in the best practices that we possibly can, right? So when I see a code review come in, boom, I'm on that thing. I'm on it quickly, and I'm reviewing each line with a fine-tooth comb. I may pull the changes locally and try running the tests myself, because I don't want my teammates' bad code to put me into this on-call bridge. And I'm also not looking at their code, but I'm looking at the unit tests, because I know the unit tests are going to be what protect us once we get into our build pipeline, right? And they're going to help keep us safe as we move forward. So I'm looking super, super carefully at these things, because I don't want to keep feeling the pain of that bad code, right? And once you do, the teams start to self-police, and we end up doing the thing that we're supposed to do. We end up doing the thing that is most beneficial for our product, and that is most beneficial for the operation of our product. And as having an operations background, I love that because I've dealt with much code that's been thrown over the wall and said, run and figure out how this thing behaves, and good luck, and you're going to be the first one called when it doesn't work. So having somebody who understands the code, who cares about the code, who's able to respond when it doesn't work is a very beneficial thing. All right. Okay. Now, another thing that changed is our branching structure, right? To help us move quickly, we used to have a lot of long-running branches. We'd have a dev branch and a QA branch and a UAT branch and long-living feature branches all over. And then our production branch. Now, the problem with these long-lived branches is that anytime you have to merge from one branch to another, you're going to get this merge bomb, right? And you're going to have these merge conflicts that are not easy or cheap or quick to fix, right? These things are difficult. And there's such a pain that we needed to get rid of those. And what we did is we adopted trunk-based development. Now, with trunk-based development, is where I'd get a user story, I would spawn a branch really quickly, but it'd be a short branch that I'd wrap everything I did in a feature flag, and then I would merge it back quickly in a master, right? I don't want that branch to exist for very long, or our main branch is what we tend to call them now, right? And so we don't want to have these long-lived, long-running branches. And by having no long-lived branches, we wouldn't have these long merge conflicts or code conflicts, because we would constantly be working off a master. At most, we'd have a day's worth of changes that we would have to deal with, means the change sets we have to resolve are much smaller, so we can merge them a lot more quickly and easily. And because we used feature flags to wrap everything, that gave us the added benefit that the new stuff that we're working on was separated from the old stuff, which was working already, and we could start to test in an incremental fashion, and also enable a bunch of other capabilities, things like blue-green deployments, and where we could turn on a feature in a new deployment, or we could do canary deployments. We could it supported our safe deployment, and rollbacks became super easy because it was just turning off the flag. Shipping the software wasn't the problem, right? Or feature release wasn't dependent on shipping a new version of software. It was dependent on changing an operational state of that software, which was turning on that flag or turning off that flag. Now, I am a huge fan of feature flags, but there is a price, right? They're if statements in our code, so there's branches in our code which increase our testing overhead. So we have more tests that we have to write and maintain. And as long as the flag option is there, we have to maintain both branches of code. If at some point that code becomes the default path or the only path, we have to remember to go back and clean up and remove that flag, remove the old code branch that is no longer being called. And yes, we can delete code because stuff's in source control, and you can always go back in source control history and find old code if you need a reference. But right, there is a cost that we do have to pay for feature flags. We determined that particular tax is worth it because the benefits outweighed the price that we had to pay. But we did end up having to put some rules in place, right? So once a feature reaches production, right, you need to make sure we go back and clean up the flags, right? Because if we just leave it around, it just clutters up the code, makes things much more difficult, helps it spin out of control. But overall, it was a really beneficial thing for us. Now, right, finally, right, these are some of the changes that we saw in our story so far. It's worked out well for us, but it's been painful along the way. We've experienced some loss. We've experienced some difficult adjustments, right? Some people think that, hey, your transformation must have been super easy, or everything just worked. Everything just worked the first time out. But it took us a long time. And in fact, today we're still iterating on these changes. Right? We're getting better every time. because it's this continual process of improvement and learning. Now, DevOps, it's not just apply a product and be done. It's not just adopt a mantra and be done, or a particular way of managing your workflows, right? It is a constant evolution and tweaking and changing. Now, who knows what we're actually going to look like if you come back and we do this talk again in a couple of years? Some of the practices and patterns that we're following may have changed. As technology changes, we need to adapt to that. And as long as we adhere to the principles of our DevOps transformation, that finding what hurts and aligning on value, we'll be all right. Thank you so much for your attention and time. And I think we have time for some questions.
Yeah, thank you so much, Stephen. So we do have one question that I'll pop up on the screen from Thomas, and it says, as a developer, I want a slowly changing and predictable platform. How is Microsoft addressing that user story?
All right. So I very much understand wanting a slow changing and predictable platform. And so what we have to do is balance the need for stability with the need for innovation. And what I think Microsoft has been good at over the years is, in the long run, maintaining things for a period of time. Yes, there are some things that haven't been, but for the most part, right, the important stable things have been maintained, and we're constantly evolving and iterating quickly on new things. Now, what we may find is that something that's beneficial for somebody might not be beneficial for the larger audience, and so it might not be the thing that we focus on and stay on, and that might change. And there's not much I can do, about that, right? But in terms of like wanting a stable platform, you can see what we're doing with, for example, .NET Core and the long-term support, long-term servicing branching, right? And same thing with like PowerShell, right? Is we can ship frequent versions, but we'll have versions that will lock in support for a longer period of time. So when you want that slow changing and predictable platform, you're opting out of some of the more rapid iteration and advancement. And we want you to be able to have that choice. And so some things you're going to see lean more towards, a faster change and advancement, but some we do have a number of platform opportunities where things are pretty consistent and stay stable for a long period of time.
Awesome.
Do you have any other?
That is the last question for right now. So yeah, I don't know if closing statements or anything else you want to end on.
Yeah, if you're interested more in more detail about our DevOps journey, we have the DevOps Resource Center on docs.microsoft.com. So come check that out. Oh, hey, another question popped up.
It says, from Lori, I believe, are the teams aligned in terms of tools and utilities, or does each team reinvent the wheel? If they are shared between teams, how does the knowledge sharing work in practice?
All right. So this comes up in a lot of my conversations around this topic. Now, we have a one engineering system, but teams aren't forced to use everything that's part of that. Right. The one engineering system provides a happy path for people to deliver software. However, if an individual team finds a different pattern, practice, or tool works better for them, then they're free to use it. If we find that it ends up being a better tool or practice across the board, that may work its way back into the one engineering system. And usually what happens, so we have shared like brown bag sessions, we have different training sessions, and there are opportunities internally to share what tools are working for you in your process. And so most teams use a lot of consistent tooling. Some teams will use some different things, and you see it in programming language as well. Like we have projects in a number of different programming languages across Microsoft. We try to align to a standardized set of those, but they're constantly being evaluated. For example, we're seeing a lot more interest in the use of Rust inside of Microsoft for a safe, low-level development environment, where we normally would have stayed, in C, C++ type experiences. You see some Go stuff happening in the Kubernetes world, right? And Go as a programming language wasn't even a thing in the Microsoft space, 5-10 years ago. So, there's always new technology and tools coming into the ecosystem, and it's just kind of a refining process. And so people have the space to learn new tools, evangelize those things internally, and then if they seem to be good, or if they get a lot of if they get some support, they might end up becoming more of a standardized tool. So there's not like one formal path that may follow. I think there is for programming languages, but just in terms of like tooling and practices, but it typically follows a pretty organic path that way. Teams don't have to teams start from a perspective of, hey, we have this pipeline that delivers everything for us, but then they can deviate from that to meet other needs.
Awesome. Thank you so much. And thank you everyone for your questions. Really appreciate your time today, Stephen. This is a great presentation. And we do have another one coming up next week. So I will share the link for that one as well. Oh, and it looks like we have one more question. If
Sure.
you have a few more minutes.
Yeah, definitely.
So they said, it looks like they may just need a link. Can you share the link to the Microsoft DevOps Center? I use Microsoft ADO at work and would like to adopt the best practices to run the sprint calls for my team. Is there a link that we could share with folks today?
Yep, and as I shared with you before, I'm working on a replacement machine today, so I didn't have that right offhand, but I will grab that right now. And let's see here. So DevOps Resource Center. So it is, I'll throw it up here. It is docs.microsoft.com/Azure/DevOps/learn. And we have a ton of stories here. We have all about DevOps at Microsoft, some learning about DevOps, all about the One Engineering system. It has a number of different stories and both text and video, covering a lot of what we talked about today and going deeper on some of the topics.
Awesome, perfect. And then we may have had one more. This one says, for some of the software, you have versions of the Windows and Mac too. I noticed, for example, in Outlook for Mac, there are certain features missing that are there in Windows. How are your teams in sync?
Yeah, so there are, Office is one area that I have less personal insight into in terms of how those dev teams operate. But my guess is that they operate similarly on the feature side of things, and that there is a team that is responsible, or a set of teams that are responsible for the Outlook client on the Mac, and some of the features that are there. And there's probably certain costs to implementing those features on that platform, and it's not been prioritized to the point of that those were important enough to be worked on at the time. The best way to provide that feedback is all the Office products have a feedback mechanism right within them, and you can pass your feedback directly onto the product team, and that really does help drive And same thing in docs, right? We can see at the bottom of this doc, there's a place for feedback there. So we've got a number of ways that you can deliver feedback, but your feedback to product teams really does matter, and they really are listening, and they do want to use your feedback to help shape the direction of our products.
Perfect. Thank you so much. And we are at time. So thank you again, everyone, for joining us today. And we hope that you can join us next week as well. And I will share the link in the chat.
Thank you so much.
And have a great day.